talk about Zeno's paradox. We are from workshop 8E. The Zeno paradox is a famous paradox widely known in the mathematical community, dating back to the ancient Greek. It was proposed by the ancient mathematician Zenos of Elea. The story he proposed to describe the paradox was called Achilles and the Tortoise, which was about a man called Achilles and his race against the tortoise. Since everyone knew the tortoise was slower than Achilles, it was given 100-meter head start. Both running at a constant speed. When Achilles reached 100 meters, the turtles would have moved 10 meters. Then, when Achilles had moved 10 meters, the turtles would have moved 1 meter. Then, when he moved 1 meter, the turtles would have moved 10 centimeters. Now, I'm going to leave it to Jason to explain more.
Thank you, Alex. As you can see, wherever Achilles have reached the tortoise previous position, the tortoise will always be slightly ahead of Achilles, and thus will always be ahead of him. However, we know this is incorrect. Achilles will have outrun the tortoise in the actual race, but this showcases the brilliance of paradise and how Zeno cleverly makes up going the mathematicians think about infinite series and how real and fun that can be. Well fun for us anyway. Give it back to Alex.
Thanks, Jason. Theory sounds correct, but why it didn't work in real world? Thinking about this mathematically, first, we need to set parameters. Let's say Achilles allowed the tortoise a head start of 9 meters, and they all running at constant speed. Achilles is running 10 meters per second, and the tortoise is running 1 meter per second. How long does it take for Achilles to catch up the tortoise? Based on Zeno's paradox, Achilles will spend infinite time but still cannot reach the tortoise. If we think this in another way, this may have a different answer. Now, I'm going to let Andy to explain why it didn't work in the real world.
Okay, thanks, Alex. By using the formula time is equal to distance over velocity, t equals to f over v, and knowing f0, which is the tortoise starting point, equals to 9 meters, t0 equals to 9 divided by 10 equals to 0.9 seconds, which shows that it will take Achilles 0.9 seconds to arrive at the tortoise starting point. And because the tortoise is also moving, so the distance from the starting point to the tortoise's current position should be calculated by using the formula S1 equals to V times T. So S1 equals to 0.9 times 1 equals to 0.9 meter. Therefore, the time for Achilles to run that distance T1 is equal to 0.09 seconds using the previous equation. 0.9 divided by 10 equals to 0.09. Now the tortoise moved even a little bit further. S2 equals to 0.09 times 0.1 equals to 0.09 meters. T1 equals to T2 equals to 0.09 divided by 10 equals to 0.009 seconds. If this continues on, we get T0 plus T1 plus T2 plus blah 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 plus Tn, n is an infinite number, equals to 0.9 plus 0.09 plus 0.009 plus blah 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 plus 0.9 over 10 to the power of n, which seems to be an infinite number because it's an infinite series. But by using the formalism of limits, we are able to calculate the result of the equation above and get the time it takes for Achilles to overtake the tortoise is actually 1 second. When the time considered at each distance becomes shorter and shorter, it becomes a convergent infinite series, which actually proves that Achilles has a finite time behind the tortoise and will surpass the tortoise in a finite time, which is 1 second in this case. This proves that the Zeno's paradox is incorrect because the time it takes to reach the tortoise is a finite number, and Achilles is able to overtake tortoise eventually instead of spending infinite time on chasing the tortoise. Now I'm going to let Brand have the conclusion.
Thanks, Andy. Overall, the conclusion of the Zeno paradox itself is wrong, but the logic of the paradox is not wrong. The reason why it is far from what happens is in reality, Zeno paradox adopts a different time system from our reality. People are used to seeing motion as a continuous function of time. While Zeno explanation adopts a discrete time system. That is, no matter how small the time interval is, the whole time axis is still composed of infinity time points. In other words, continuous time is the limit of discrete time, which takes the time interval as infinitesimal. This also illustrates the elimination of formal logic in describing the physical world. Thank you for listening, and we hope you found this paradox to be as fun and interesting as we did.
Thank you very much, guys.